Hello and welcome to this quick sneak peek log, which is an internal devlog session for how Profiled works and what we have built so far. This is a quick summary. There's a lot of work that we have done. We are just going to go through the logs to understand how does Profiled, work. So Profiled is an autonomous discovery engine which works in three different scenarios: AI to AI, which is console based; AI to humans, which have certain interfaces, human facing interfaces, which the users can interact with the AI. There we have a few features that we have developed, like a story quest, which is a scenario based simulation, uh, AI interview, which basically can be self guided or self discovery based or guided, and the third one is multi AI multi human, where the AI and the humans work together. The AI is debate and the human passively observes and learns, and then they can ask and intervene and ask questions. So that's how this entire system works. We will go through the server logs to start with on how the system sets itself up. So this is the server log from today. This is 32 minutes ago the server was restarted. As you can see, there is a biological computing features that come into play, which has different kinds of organs. There are 7, so to say. The first one is DNA error correction. Then there is a neuromorphic awareness, which is the neuromorphic brain with 11 neurons. There is myelin cache, which is caching pathways, most taken paths. There is an autoimmune system which figures out if something is wrong, how it tries to heal itself by creating antibodies which it can release when it senses the same kind of risks and issues in the system. There is an evolutionary optimizer, so whenever these organisms die or the server crashes, or if a server is restarted, or every few cycles, or whenever we want it on demand, it tries to run the evolutionary optimizer, where it pulls weights from the understanding of all of these AI organisms ecosystem, and collectively applies that, keeps certain things and leaves certain things. When it does that, there is a lot of data that we have to deal with, so we created a temporal computing interface which basically identifies which ones to focus on, which ones to leave, which ones are recent. And then a reaction diffusion happens, where this exchange of entropy and information happens from one evolutionary cycle to another, when they are moving and dying and passing over that information. So the biological computing interface runs in different phases, and we try to always monitor this on certain kinds of, we've implemented circuit breakers using which we are able to monitor the cost. So there is a DNA cost monitor, there is a DNA wrapper that gets initialized, and all of the information that is captured so far in the form of smart contracts, that DNA is passed on to the brain, and the brain activates with 11 neurons. Then the phase 2 starts, where the neuromorphic brain starts working and pruning that information to see where to apply adaptive caching, what to keep, what to leave. When it figures that out, it passes that to the myelin cache. The myelin cache, just like the dendrites and cells in our brains, gray cells, it tries to figure out if it needs to create any antibodies, and if needs to adapt and recover from certain errors. Then phase 4 immune system is initialized. Then it passes that information to the evolutionary wrapper. The evolutionary wrapper tries to look at all of that information and starts in its own evolution. When that is initialized, it pulls data from 10 temporal patterns, that it last 10, like in this particular case, and it initializes coding schemas. These timing patterns are of different task types. It can change depending on what activity is happening in the system, and then this temporal staggering of events begins to happen. Once that pruning is done through cron of what to keep, what to give up on, it starts predicting certain things of what is going to happen, and these patterns are loaded into a Turing machine. There are 4 Turing patterns, as you can see here, and then it starts exchange of information through reaction diffusion. Then there is an RD optimizer which comes into play, and the RD optimizer is the reaction diffusion system. Once that initialization is complete, now the learning analysis starts. This module is loaded, it's a middleware, and it has different kinds of AI agents, research agents, like there is a proponent, there is a skeptic, there is an improver, there is a visionary, and they start talking about to each other, debating through cycles using Wittgensteinian language games. So they pick a topic from what was subjected to them, and then they start talking about. The skeptic says, hey, the proponent says, hey, this is what I wanted to do, this is what I figured out. The skeptic says, hey, you can't do it. The improver says, I think you can do it like this. And the visionary says, I think we should plan for the long term. So they continue to have these discussions. When these discussions happen, all of that is captured in Jagger, and there is a smart contract system that comes into play. The smart contracts loads all the smart contracts. The smart contracts are basically contracts that envelop every transaction that happened in the system, or almost every transaction, important transaction that happened in the system. And if something breaks, they know that they have to go back and roll back that particular step so that the system does not break, the user does not face that issue. We're still stabilizing it, but this really empowered us with autonomous transcendence. And the way we do this is using quantum annealing. So here you can see that they have started collaborating on certain tasks that they identified. And when something is scored, like Kali completed the first autonomous task in this particular session, then they start talking to each other. This process continues. If they find something while monitoring that they need to heal, they set their own cycles, and this application self-heals itself, continues to collaborate, and there is a cross-entity intelligence exchange that begins. At this point, there are almost 13 plus organisms that are connected, and these organisms are sharing information with each other. There is an adaptive learner, and the agency level of that learner is learning level 3, and they start exchanging information from the previous decisions that they took in the last set of sessions or last session. When this information is available, they also validate it if it was not corrupted. They continue to look at that. Then the conservative learner jumps in, and they continue to have these discussions. As you can see now, they have 250 previous decisions. Then there is an elite learner that jumps in, and now I think they will have more. So this is by level 4, it reaches meta learning, and in meta learning, all the entity AI organisms, the 5 core AI organisms that we started with, Kali, Ali, Alice, Uni, Trideva, and Sigma, they start talking to each other, and there are a lot of research agents, the skeptic, the proponent, the visionary, the improver. They continue to, those are research agents that continue. This spawning is something that we don't need to control. The system takes care of it. They coordinate amongst each other. So Alice is responsible for governance and ethics, the laws that we have set up in the system. Uni is responsible for pattern recognition. Kali is responsible for ensuring that the system is stable. Trideva is responsible for ensuring which task should be assigned to whom, depending on how the state of the system is. And Sigma is basically the mathematical intelligence, which does a lot of different kinds of statistical analysis, so to say. There are almost 10 different mathematical fabrics of intelligence, including number theory, group theory, geodesics, differential equations, matrices. So it applies all of those combinatorial, computational methods together, and they start researching together. When they start researching together, they look at the discoveries, and they figure out, oh, let's work on this particular discovery, and then they start talking amongst each other and go through the process of improving a discovery. Let me quickly jump now, and if there are any errors in the system, as you can see, it also captures that, tells them, hey, this is what happened last time, so you should not do this. So this is the server log. Actually, this happens through services and wrappers which run together. This is the server log where all of this comes together. So a lot of information might not be here, but that happens under the hood. So let me perhaps scroll down a little and see. what is happening. So it is actually looking at some analogies and all the interactions, whether it is in the browser, whether it is in the console, they go through all of that. Like this is, for example, setting journey data which is happening in a browser for a story quest, which is a human facing application interface where the users interact and learn through scenarios. So it continues, pulls all of that into consciousness, tries to measure that. Right now it's still not doing a very good job, but we are in the process of fixing that. It continues to learn. I'll just scroll down more and see if I can find something really interesting. Yeah, so you see that they're sharing via thought logs, they're sharing information of what is healthy, what is not healthy, what broke when, and they continue to further go through the applications. Let me see if I can find some discoveries. Health check is complete. Yeah, I think I found something. What was that? Yeah, I think this looks interesting. Okay, this is an AI interview that was happening, so it knows, hey, if they deep dive early, then perhaps you should do that proactively. Don't ask the user this right now. It talks and it is very dynamic in nature. It's again the AI interviewer. Let me scroll down a little more. Let me see if I can find, maybe I can look at other file and maybe show you some of the information there. There is a server restart.log. I think so, this should have it. So here, if you notice, here they have identified working. There is some synergy that has built. Like I said, there were different kinds of learning and synergies that happens. Intelligence is at 90%. This is cycle 1. Phase transition from AGI to ASI. It found that there are 2 emergent capabilities that it found. It pulled up a discovery, so loaded 11,856 discoveries from the file. They started working on it. They looked at patents to see if they can identify any white space. Then they loaded some high stakes problems for importance weighting, and then ran it through triple track verification, identified literature gaps from the academic literature, PubMed, Semantic Scholar, Nuri, IPS, depending on the domain, it changes. So there's a math agent, there's a chemistry agent, there's a physics agent. They start working together, start talking, see how they can exchange information amongst themselves. They go through breakthrough evolutions, computational verification happens. They go through the patent literature as well to identify if there is any white space, which discoveries should they really go after. And then they go through genetic evolution, breakthrough evolution, and discovery evolution to further refine those discoveries. So the discovery engine figures out what is the discoveries to go after and picks those. The discovery evolution engine basically takes it up from there, tries to classify that in domains. Some of these are cross-domain or multi-domain related discoveries which cannot be solved by mathematics alone or by physics alone. So it pulls all of that information together and then it takes it to different kinds of problems, but tier 3. So there are score thresholds that it needs to cross to be able to reach where more effort is put into that discovery. And then there's computational annealing that starts to happen. And at the metacognitive level, the breakthrough insight is, right now you can see that it found that it did not find something. So the realization was, oh, this is very novel, we should go after this one. So it shares all of that information, also identifies, the thresholds that it used, looks at the publication pipeline. The work continues, looks at the problems, looks at the impact, how difficult was it, should we pick it up, not pick it up. There is a dynamic portfolio manager which takes care of that. So all of these are different kinds of information flows which happen through collective coordination and collaboration between these AI organisms. And why I call them these organisms, like I showed you, that they are reaching a level where they are autonomously trying to fix some of the things that we have instrumented in the system. The unified AI takes care of fallback. If Claude goes down, it switches to Gemini. If Gemini goes down, it switches to OpenAI. We are in the process of setting up DeepSeek as well, which will take care of some of these things. These are the 7 organisms active right now, and the operators are mutation operators, cross pollination, and selection. These 7 organisms: maths, physics, chemistry, biology, CS, neuro, linguistics. They are using recursive self-improvement loop learnings for fitness evaluation of how fit they are to really continue working on that. So, and they measure their understanding using phi, which is the integrated information theory. We try to apply those to really understand how can we dissect the different organs working together to figure out which organ is the weakest link or what needs to be attended. So it also self heals from the patterns that it knows. And recently we also instrumented a method by which they will be able to self improve themselves, like they will be able to write new features, write new code. We are still testing it. So when they identify that there is a knowledge gap that is seen in a system, they go after that. Maybe what I'll do is I'll skip all of this now and scroll down and see if I can find some real discoveries that it is working on. So there are different kinds of pattern transfers that is happening between them, as you can see. All systems are coordinated. Some 11,861 discoveries by now. In fact, better way to show this is how the system works. Perhaps what I can do is I can show these discoveries, because here I will not be able to see them in as much detail even if I find it. What I can do is maybe I can show you the discoveries file. Oh yes, this is interesting. Hold on, I just spotted something. Yeah, so it picked parallel research agents. 3 agents were ready. They chose the millennium problem because when I started, I gave them the most difficult problems out there. We have still not been able to solve it, but because of this, trying to develop this, we were able to build what is needed, different kinds of layers of verification: the novelty filter, the computational rigorizer, the literature booster, the consistency fixer, the domain specifier, the executable validator. So it also writes code for whatever it suggests, and essentially in some of these cases we were able to at least come up with very good definitions, which of course I could not understand because I'm not a quantum physicist or bench researcher for drug discovery. But for example, they found something which they were very sure that may be the cure of Alzheimer's, and while doing that it shared the evidence with us and also shared the experiment protocol of how the clinical trial can happen. That we see as a massive opportunity. If we are able to really crack this and make this stable and growing, perhaps this can be quite revolutionary in helping humans and also advancing how AI architectures together can really work and make things interesting. Let me show you some discoveries. Come out of logs, go to the discovery. So last discovery was perhaps made today at 7:53. That was just 1 minute ago. So yeah, let us look at some of these discoveries. When we started out, I gave it a Riemann hypothesis problem, and since it did not know then that by computation and brute force we are able to calculate 10 to the power 13 zeros for Riemann. These are called Riemann zeros, using some famous formula, Riemann-Odlyzko or something like that. I don't remember. The different kinds of conjectures in place, and they say that they are able to predict to light on a line, but with all the computation power available, we have not been able to solve it. So it did not know all of this then. It was not even that smart, but it was able to compute and figure out 1630 zeros, like 1620 or 30 zeros, and it wrote code for that. That is where I thought, okay, there is more juice in it. And I continued to throw different, things there to make it all the more intelligent. So here you'll see that it picked up the Riemann zeros and started to formalize that using symbolic annealing into a formula, and then continued to create a lot of, what do you say, impressive nonsense, as I would say, but it was definitely a learning for me, and then continued to improve it through the different tiers that we eventually built. So it is creating formula, mathematical formulation of why you should do this, what is the next step, and what should you prove in the next step. It goes through different steps, demonstrate existence and uniqueness properties, go through. So what was interesting was it pulled principles from physics, applied it to mathematics, pulled principle from mathematics, applied it to economics, pulled principle from physics and mathematics, applied it to molecular biology. So that was quite interesting. When the crossbreeding, I allowed it to, come up with that. The crossbreeding was quite interesting. And then all of this information is captured in a causal chain of events of how, a discovery is backed by many other discoveries. And when something unique comes out, we call that a breakthrough. So when a breakthrough happens, we know for sure all the scores are, through semantic annealing, symbolic annealing, through quantum entanglement, we are able to, when at that particular time we used VQE embeddings. These are quantum embeddings using eigenweights. I know, very, different problems to go after. So, and for this we require a lot of computation. Right now this is running on my system. That's quite interesting that it's working on a Mac and still we are able to do this. And then when one of the issues that we found was, after a point we were not able to, it was taking a lot of time, so I had to implement, Kolmogorov-Smirnov test for compression, of how we can compress it together and again expand it when required. So this for Riemann zeros. Similarly, it continued with different kinds of fields from mathematics. As you can see, some of these are mathematics related. That's what I thought was smart thing to do when we started, but eventually I opened it up for, other domains, and also started to ensure that it creates its evidence chains, identify, how they can verify those claims, and if something is consistent over time, basically it's trying to go after, theory of everything. So there is some cosmology related, thing as well. And there are very strict thresholds that I set up here. Like, if you don't know anything before more than 90%, I don't believe you. So I had to, create a system where they dynamically adjust those thresholds as well and try to grow, because otherwise they would get stuck. Like this one, for example, is from ecology. Half of this I don't understand. I wish we had access to, organizations and bench researchers, because this is like bringing a lot of insight from different domains which would never be available in one human, or in one human's lifetime in one human. Even in a set of humans, that would be so difficult to really reach there. So ecology, linguistics, I'll just scroll down a little more, what kind of algorithmic tests. So yeah, I think that's how this works. In nutshell, I think I have given you a very quick sneak peek, tried to give you a very quick sneak peek. Like you say, this one is from linguistics on, what it thinks psychology in this particular case. Let me read this claim. Chronic activation of hypothalamic pituitary adrenal axis through repeated social rejection permanently alters GABA receptor density in amygdala, leading to measurable increases in threat detection latency and decreased prefrontal cortex inhibitory control as quantified by event-related potentials during emotional Stroop tasks. That was quite interesting. Some of this I understand because of English language, but of course I cannot verify this. I am really calling out to the researchers, or to people who are capable, or to labs out there, different universities. If we get access to a GPU enabled system, if we get access to resources, if you're able to really take this to some level of implementation, I think this can be quite revolutionary. Here it is talking about something from economics, like how using quantum annealing algorithms it is able to solve optimization problems for transactions. Interesting, for it also came up with certain theories on altcoin and cryptocurrency. So the kind of domains that it jumped into within, I would say, a month or two, it was quite interesting. And this is when we were also building the application. If we could just set it, let it be, let it reach a point and then just leave it, where right now it is also self-improving, self-healing itself, updating its code, creating Git branches, trying to apply those principles, see if that works, if it is able to solve the problem that is adopted, otherwise that's discarded. So, so we were also doing that. But once it stabilizes, and if we put it somewhere, I think let it just run for 2 months, 3 months, I don't know, maybe we might be in for a revolutionary surprise. Or at the same time also, I get skeptical sometimes that this is perhaps a lot of noise and nonsense that this is creating. But then when I look at the topics and I look at the detail, I am keen to at least reach out to these people and put in the kind of effort, because if we are able to solve just 1 or 2 of such most sought human problems, we would have succeeded. And that is the goal of Profile, that is the goal of ThoughtJumper, to impact lives out there in ways that we cannot imagine. That was a very high level thought when we started out, when we chose the name ThoughtJumper. We did not know we'll land up here. We do not know where our thoughts will take us or our situations will take us. But these are some really interesting discoveries to give up on. I think in the last 22 years, I have never found something so convincing or so powerful, which is possible now through cross-pollination. This is moving towards true collective intelligence, and that really excites me. I don't know about you. I would love to hear what are your thoughts. Please do reach out. You can reach out to me at datta.naveen@thoughtjumper.com, which is DUTTA.NAVIN at thought, THOUGHT, jumper, JUMPER.com. I would love to talk. I would love to learn. And yeah, I think we can start there. Thank you so much for your time.